Hello viewers, tutorial 5 question 4, and we're finding equations of graphs. So we see on the left a straight line which has a y-intercept of 9 and an x-intercept of 3. Since it's a straight line, we expect it to have the form y equals mx plus c, but we'll do it the x-intercept way, which is y equals k times x minus a. So what is a here? A is your x-intercept, which is 3. So y equals k times x minus 3. Now we need to find one other point other than the x-intercept that it goes through, which is the y-intercept will be just fine here. So on the y-intercept, x equals 0 and y equals 9. We are expecting c to come out to be 9 because that is our y-intercept. So if we substitute this line into our equation, what are we going to get? Y is 9 equals k times x is 0 minus 3. So therefore 9 equals 0 minus 3 is negative 3 times k, and if we divide that by negative 3 we get k, which is 9 divided by negative 3 is negative 3. So we get k equals negative 3, and therefore if we put that back into that line there, we get y equals negative 3 times x minus 3, which is negative 3x plus 9. So we do indeed get our expected value of c equals 9. Question B, on the right we see that we have a cubic. It has that cubic shape about it. So we also have two x-intercepts, which are negative 10 and 3. We can see that it's turning right on the positive 3 intercept, so that means it's a double intercept there, and it's got a y-intercept of 90. So it's a cubic, so y is k times x minus a, x minus b, x minus c, and y equals k, x minus, well, a is negative 10, so this is x minus negative 10 is x plus 10, b is negative 3, and because it's turning right on this line, we count that intercept twice, so c is 3 as well. Okay, so now when x, so we need to find a point that it goes through, which we can again use the y-intercept. So when x is 0, y equals 90. Let's substitute that into what we have. 90 equals k times x is 0 plus 10, x is 0 minus 3, and x is 0 minus 3. So 90 equals k times, that bracket is 10, this bracket is negative 3, this bracket is negative 3, 10 times negative 3 times negative 3 is 90, so this is 90k, so we get 90 equals 90k, so that tells us k equals 1. Okay, so we put that back in that line, y equals 1 times, well, if it's 1 times we don't need to write it, x plus 10 times x minus 3 times x minus 3 again, so that's x minus 3 squared. So that's our equation of the cubic. Okay, so next we have the following graph, which is an upside down exponential. So it's got a line that it follows, a horizontal line that it follows, so it's got a horizontal asymptote. It never crosses this x-axis, which means that it's an exponential. So y equals a e to the kx. We know 2 points that it goes through. We know it goes through, it's got a y-intercept of negative 3, so it goes through the point 0, negative 3, and it also goes through the point 4, negative 243. So let's substitute the 2 points in. So when x equals 0, y equals negative 3, and and therefore if we substitute that in, we get negative 3 equals a e to the k times 0. K times 0 is 0, so this is going to be a times e to the 0. But e to the 0 is 1, so that's a times 1, which is a. So we've got negative 3 equals a. Let's substitute that into y equals a e to the kx, and we already know a. So y equals negative 3 e to the kx. So we have one other point that we can substitute in. When x equals 4, y equals negative 243. So let's substitute that in. We get negative 243 equals negative 3 e to the k times x is 4. Okay, so we need to solve that equation to find k. So we can divide both sides by negative 3. Negative 243 divided by 3 is positive 81 equals e to the k times 4. Let's write that 4k. So therefore we need to get rid of this e, which means we need to take ln of both sides. Ln of 81 equals ln of e, which is going to cancel out to give you just 4k. So therefore k equals ln of 81, and that will be divided by 4. And if we calculate that, we get 1.099. So that's the value of k, and therefore your graph is negative 3 was our value of a, e to the, we just found k to be 1.099 times x. So that's the equation of this upside down exponential graph. Notice that I said upside down there, which means that we do expect a negative number out the front. Okay, question D. This time it's following the y-axis, which means the y-axis is a asymptote. It's now got a vertical asymptote, which makes it a log graph. So if it's a log graph, it's got the form y equals a times ln of bx. Doesn't really matter whether we use bx or kx. What letter we use is totally optional. Okay, so it goes through 2 points that we see. It has an x-intercept of 2, so it goes through the point 2, 0, and it goes through the point 10, 1. So when x equals 2, y equals 0. Substitute that in, so we get 0 equals a times ln of b times 2. Let's write that 2b. Okay, so we've got 2 unknowns there, but we can say that with certainty that a is not 0, which means if we divide both sides by a, we get 0 equals 0 divided by a is still 0, so 0 equals ln of 2b. Now we need to get rid of the ln, so to get rid of ln we need to take e to the power of both sides. E to the power of 0 equals e to the ln, so that's going to cancel on this side to just leave you with 2b. So therefore 2b equals e to the 0, which is 1. So therefore we can say that b equals 1 over 2, which is 0.5. Okay, so we now know the value of b, which is 0.5. So we can substitute that into y equals a ln of bx, and let's do that over here. So we get y equals a ln of b, we now know to be 0.5 times x. And we have one other point that we can use. When x equals 10, y equals 1. So if we substitute that in, we get 1 equals a ln of 0.5 times 10, and we can work out what's inside that bracket, which is half of 10 is 5, and therefore a is going to be 1 divided by ln of 5, and if we calculate that, we get an answer of 0.621. So our equation is a ln of bx. A we've found to be 0.621. ln of b is 0.5 times x. Okay, thanks for watching. Over and out.